Welcome to another JPJ Discovery video. Despite centuries of study and decades of exploration, there remains much we do not know about our solar system. And as the planets and moons swirl in an endless dance about each other, a mysterious hidden partner has long been rumored. Nemesis, the hypothetical dark companion to our sun, may lie out there. Proposed to explain Earth's periodic mass extinctions, this elusive star remains a tantalizing enigma. Despite decades of speculation and numerous searches, scientific evidence for Nemesis remains elusive. Are we truly orbiting the sun with an unseen companion, or is Nemesis a cosmic phantom? Some astronomers have hypothesized that our solar system doesn't just have one star. Instead, they believe the sun could have a companion dwarf star, which they've dubbed Nemesis. Why the ominous name? Well, scientists speculate that this dark destroyer could affect the orbits of objects originating from the far reaches of the solar system, sending them careening towards Earth and periodically causing mass extinction events. Nemesis's existence was first postulated in 1984 by Richard Muller of the University of California, Berkeley. He began working on the theory after he and other scientists noticed that mass extinction events on Earth appeared to have a cyclical pattern, happening every 27 million years or so. It was decided that with such long time spans involved, the only explanation could be astronomical. Space is very, very big, and it takes a long time for anything to get anywhere. The theory evolved with later researchers suggesting Nemesis could be a brown or white dwarf, or even a star so small it's barely bigger than Jupiter. All these kinds of stars are very dim, which would explain why Nemesis hadn't been spotted previously. Muller and his colleagues believed that if Nemesis was located beyond the Oort cloud, a ring of icy rocks orbiting around the sun past Pluto, its sheer size means that its gravitational pull could affect this band of asteroids. The massive chunks of ice that make up the Oort cloud streak through the solar system in an elliptical orbit, and as they get closer to the sun, they melt, leaving a tail behind them. These are comets. It's been speculated that if Nemesis's orbit takes it through the Oort cloud every 27 million years, its gravity could kick out extra comets, sending them hurtling toward the inner solar system. The law of averages means this would lead to more impacts on Earth. More impacts would mean more extinctions. It's a nice theory, but not everyone is convinced. There are a few problems with the Nemesis theory. One of these revolves around the idea that Nemesis could be causing mass extinction events. Fossil records do seem to show that extinction events seem to peak or become more common around every 27 million years. The problem is that besides a handful, there's no evidence these extinctions were caused by meteor impacts. The kind of impact needed to cause a large-scale extinction event would need to be exceptionally large. Unfortunately, there aren't enough craters of this size, and the ones that do exist don't all line up with the 27 million year pattern. On top of this, not all astronomers are convinced the math adds up when it comes to Nemesis's orbit. The fact Nemesis doesn't appear to affect the orbits of planets within the solar system means it must be very far away and very small. However, many astronomers believe such a distant orbit would be incredibly unstable because at that range, Nemesis would come under the influence of other stray stars traveling through the galaxy. There's also the problem that no one has spotted it yet. A star as far out and small as Nemesis supposedly would be, but telescope technology has come a long way over the last few decades. The ultra-sensitive telescopes used by today's astronomers should absolutely be able to spot Nemesis. Over 4 years, 2 teams of astronomers carried out the advanced 2-micron all-sky survey using the world's most advanced telescopes. They scoured the sky in 3 infrared wavelengths looking for stars. They found 173 brown dwarfs outside of our solar system. None of them fit the bill for being Nemesis. Likewise, from 2010 to 2011, NASA's Wide Field Infrared Survey Explorer found some brown dwarfs closer than 20 light-years away. None of these were located close enough to be Nemesis. The failure of these and other surveys to find a likely candidate has led many astronomers, including those working at NASA itself, to declare that Nemesis does not exist. The sun is a lone star, and that's the end of the story as far as they're concerned. So, if Nemesis doesn't exist, what about the 26 million year extinction cycle? Other celestial goings-on could be responsible. It's believed other events happening either within or outside our solar system could be affecting the Oort cloud, or they could be sending cosmic rays into our atmosphere, triggering climate changes and extinction events. The dwarf planet Sedna lends further credence in the eyes of some to the existence of a companion star for the sun. Though some scientists find the Nemesis theory plausible, others do not. The initial cyclical nature of mass extinctions is still under discussion. In order to avoid significantly affecting the orbit of the planets, as well as to avoid observation, Nemesis must remain at a distance from the Sun. But astronomers argue that such an orbit would be inherently unstable. A 2017 study found that the majority of stars like the Sun were indeed born with companions. However, they also found that over time these companions drift away and break free from their bigger siblings. The Sun is not part of a binary star system. There has never been any evidence to suggest a companion. The idea has been disproved by several infrared sky surveys, most recently the WISE mission. If there were a brown dwarf companion, these sensitive infrared telescopes would have detected it.